Hi, Mr. Pepperell here, and in this video I'm thinking about what do we actually mean when we say something's hot. So by the end of this video you should be able to say what we actually mean when we say an object's hot and describe what happens to the particles of material when the temperature increases.
So what do we mean when we say something's hot? Well, let's have a look at a couple of pictures here. I've got some ice and I've got a nice cup of coffee. Okay, now it should be obvious to us that in this case here, the ice is obviously cold and the coffee is the one that is hot. But if I add in a third picture of a volcano, okay, and I look at the coffee and the volcano, I can now say that obviously the volcano is very hot, and compared to it, the coffee is actually cold. Okay, so by saying something is hot, all we can actually say is that something is hot compared to something else which is cooler. So in this case, the coffee is hot compared to the cooler ice, but the volcano is hot compared to the cooler coffee. So that is hot and cold, but what about actually measuring the temperature of something? Well, to do that you need one of these things, which hopefully you do remember is a thermometer, and that measures temperature in degrees C, okay? But what does the temperature of something actually tell me? Well, let's think about our ice again from earlier. If I start to heat up our ice using my Bunsen burner there, okay, it should be obvious to us that the temperature is going to rise. Now, to understand what this means, we need to think about energy. If I heat the ice, okay, heat energy is being transferred to the ice from the flame, or in fact, it's actually being transferred to the particles of the ice cube. Those particles are actually vibrating already, although we can't see it with our eyes, okay? And when we heat them, this heat energy is converted into movement or kinetic energy in the particles, okay? So when I start to heat the particles, the heat energy is transferred to the particles as movement or kinetic energy. The more heat energy I transfer to them, the more kinetic or movement energy they've got, and the more they start to vibrate. So the more I heat the particles, the more kinetic energy they have, and the more they vibrate. And eventually these particles will start to vibrate so much that they vibrate out of their fixed positions, and our solid cube of ice turns into a liquid puddle of water.
So now we know the temperature of a substance is actually a measure of how much kinetic energy its particles have got. And this is a really important idea that we need to take on board for a lot of our future work in physics. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.